let's go through the warm-up. The first 5 are going through properties of exponents, radicals, rational exponents, and then the bottom is addressing solving, okay, because that's what we're getting into today. So, for number 1, what did we get? Danielle? 3 times the cube root of 2 over 4, okay? Because the 1/3 is the cube root of 54 and the cube root of 64. Cube root of 64, there's a perfect cube, which is 4, okay? Then the cube root of 54, we have 9 and 6, 3 and 3, 3 and 2. Since it's a cube root, we're looking for 3 of a kind, okay? Whatever's not circled stays inside. How many of you did get number 1? Awesome, good. Okay, number 2, someone else, Addison. Excellent. The cube root of x squared over 3. Remember, some of you are probably used to just distributing this guy and then rewriting what you can, okay? Eventually, in 5.4, we will be rewriting the space so you don't have to do that, okay? But this is perfect, what you have here. All right, number 3. Go ahead, Braden.
I'm not sure if I have this right.
It's okay.
X to the 6 with the cube root of y and then divided by y.
X to what power?
The 6.
Okay. Too much, okay? But everything else was correct, so it's just your x. You did phenomenal. So we're going to take care of this radical first. Cube root of 64 is 4. Cube root of x cubed is x. We cannot do anything with the cube root of y, so we're going to keep that as is. Then we have 4, this x to the negative power, to make it positive, comes up top. And then we have our y. So we have 4x to the 4th cube root of y over 4y. The last thing you could do, and I'll move this up so you guys can see, is cross out the 4's, okay? So x to the 4th cube root of y cubed over y. That's as far as you could go. In my last class, rewrote the cube root of y to the 1/3 and then try to subtract. You're back to square one. Because one thing you have to remember, you cannot have radicals and or rational exponents in the denominator. Okay? So if you did do that, you would end up in the bottom y to the 2/3. But you can't have that. So you would multiply top and bottom by 1/3, which is a whole nother piece. How many of you did get number 3 correct? Okay. All right. Now, the reason why you do not move this up until you're done evaluating that cube root is because this has a radical, this does not. Okay? Any questions on number 3? Yep, Liam. It's negative. To make it positive, you bring it to the top. Okay? All right. Number 4. What did we get for an answer? No one? 24? What's that? Go ahead. Excellent. Okay. So we're taking the 4th root of all of this. So each we have 3, x to the 7th, y to the 9th, z to the 3rd. So we cannot take the 4th root of 3, so that stays inside. Then 4 goes into 7 how many times? Once. How many are left over? 3. Okay. 4 goes into 9. How many are left over? Can 4 go into 3? No. So we keep that inside. And that's exactly what Sad said. Okay. How many of you did get number 4 correct? Good. Okay, number 5. Go ahead, Taylor. 1 over 625. So we have the cube root of 125 to the negative 4th. Take the cube root first, which is 5, to the negative 4th. We can't have a negative exponent. So 1 over 5 to the 4th. And then if you do that out, 625. Okay? Questions? Yep. It's the cube root because it's all raised to the 1/3. Okay? Yeah? All right. Now 6 through 9 is solving. Okay? For number 6, what do we got? Genevieve. Plus or minus 3. Excellent. You divide by 2. X squared equals 9. When you're taking the square root, you must remember plus or minus. Excellent. Number 7. Caitlin. Anything in front? Excellent. So you add 7 and you get the square root of 12. Okay. X equals plus or minus 12 is the square root of 4, square root of 3, to root 3. That's your final answer. Okay. All right. Then 8 and 9, we are factoring. How do I factor number 8? Or what are your solutions? Let's go with that. Go ahead, Grace. Excellent. Okay. So we have 3x squared plus 9x plus 1x plus 3. Remembering your factoring. Okay. Split the middle. 3x, x plus 3 plus 1. Okay. Group together your outside in one of your parentheses. Now, it's set equal to 0. So you're not done until you solve. So you have x equals negative 1/3 and negative 3 as your 2 answers. Okay? How many of you did get those? Good. All right, number 9. What are the solutions? Louise. Excellent. Good. This is quadratic form, meaning our exponents are doubled. So factored form is as it is what you see here. You could set those both equal to 0, okay, from there. But for practice, for difference of 2 squares, I am going to expand that out, okay? And your solutions, 3, negative 3, taking the square root, so must have plus or minus. Okay, and how many solutions do we have in that last one? Go ahead, Edison. 4. What's our degree? 4. Okay, so in this case, we have all 4 solutions that are shown on the graph. When we get into some solving today, we might have an exponent that's to the 6th, but we only see 2 actual solutions. Okay, but before we get into today's notes, on the homework, and I wrote a little comment for you. Number 6 should have been 1 over y to the 21st, not 17, because it was a negative exponent to go to the bottom. Okay, some of you, half of the room saw the corrections or wrote, you had a note there. So number 6 was 1 over y to the 21st. Okay. Any questions on that first page? Page 4. Brayden? 12. Okay. I'm going to show you another way than what's on the key as well. Okay. When you're multiplying fractions, write it under 1. So everything is in order. So I'm not going to combine. I'm just going to keep this as is, my numbers together. and then y to the 11th, z to the 7th. Then I have 4 and 9, y to the negative 2nd, which we'll take care of, and z cubed. So it's under 1, so you could see. Okay? Now, looking at our y's first. This negative exponent should go where? To the top. So we have y to the 11th times y squared, which is? Y to the 13th. Good. Okay. Now, what do we do here?
Divide, so it'd be c to the 4th.
C to the 4th. Excellent. Okay. So now, with our numbers, can we cancel out anywhere?
5, well, here you can simplify by 6.
Okay.
Or 12.
Well, just looking at it, what we have, because I kept it just as is on this case, I'm going to cancel out my 3 here, right? Cancel out 4 that way. Okay? Then you're left with 2/3. But again, if I was to multiply 24 over 36, you could reduce as well. Okay? That's the same thing. A lot of you had question marks or just left it blank, number 15 as well. How many of you had questions on 15? Well, not as many. Some of you did. It's okay. Thank you. So for 15, and I have to grab the other because I crossed out everything. I would do, if you looked at that and you're like, yeah, no, I'll come back to it another time, I would put it with one fraction. So this was 2 to the r, 2r. And again, there's multiple ways to do this. But with these types of problems, a lot of mistakes happen. Okay? So having that, and this is for those of you that were not sure, r to the 8th and r, it's r to the 9th, s, oops, there's another one here. R to the 10th, s to the 8th. Then we have our negative 3, 4, 24, right? And then r to the 8th, s cubed. So right now you could take care of your variables very simply. This is easier to see. A lot of you did cross cancel or just copy down the answer. Either way. Okay. R to the 10th over r to the 8th is what? R squared. Then r to the 8th divided by, s to the 8th and s cubed. S to the 5th. And then I go ahead and cancel. Our 4s can cancel out. 3s, this is a negative 1. This is a negative 3. And then we're left with 2 over 3 as your final answer. Right? Again, multiple ways to solve this.
Did you cancel it out because they're the same like numbers?
Mhm.
Oh.
Mhm. Yep. Yep. All right. Yep.
Good question. Do we need
Which
to,
one?
9.
Mhm.
Do we need to like distribute to each number? You know how normally when it's like.
Nope. Because there's no. Nope.
But would we have to do that if there was like a plus sign or something?
Plus sign, yes. Mhm. Yep. Anything on page 5? Addison? Yeah. Okay, this came up in the other class as well. Again, you could do this a variety of ways. You could multiply these two together, then divide by 3 or reduce it. For now, I'm just going to simplify each of these radicals. Or you can multiply 81 over 8, get that and simplify it that way, whatever you want. So the cube root of 81 is 3 times the cube root of 3. Okay, we get that by 9 and 9, 3 and 3, 3 and 3. Okay, what is the cube root of 8? Danielle? 2. And then I have this guy here. Anything I cancel out? Yep. So you have 6. If I was to combine it, this is what it would look like. And then you just cancel out those, and you're left with 6. Okay, but again, that's one way. I might have done a different way on my sheet. But again, either way. Okay, multiple ways. Yep.
You go for 36.
Did I cross it out and put 36?
Oh,
That's
yeah,
okay.
36.
Okay. God bless you. Okay. So the numerator here, they're the same base. Okay. So I could add these exponents and get 29 to the negative 2/5. And then we have 8 to the 2/3. Okay. So with the negative exponent, that's going to go to the bottom. Okay. Now looking at 8 to the 2/3. Okay. And there was more to this problem, but I left it as is because we didn't get there. We would take the cube root of 8, which is 2. 2 squared, 4. So 8 to the 2/3 will be rewritten as 4. Okay, 4 times 29 to the 2/5. We could have went further by getting rid of that rational exponent, but I didn't want to confuse you guys too much with that. Okay. Any other questions on the homework? Yeah, Genevieve. The one that I crossed out, or okay, so it's 8x to the 1/3, right? So that's, God bless you. That means the cube root of 8x. Okay, so eight x to the 1/3 is the cube root of this entire thing, right? So the cube root of 8 is 2. We can't take the cube root of x. So that's as far as you would go. You could write it that way or 2x to the 1/3. Either way. Okay? All right. All right, take out your notes and turn to page 11. My note packet, turn to page 11. And those of you that kind of keep track or like to plan, we're going to start 5-3 today. We will finish it on Tuesday and start 5-4, which again is solving. It's very, very short, but it's a different way of solving exponentials. Tentative quiz. It's probably going to be next Friday. So that's not next. Yeah, next Friday. April 1st, which is April Fool's Day. I was going to have it for Wednesday, but I think we'll have it Friday, even if we continue on Wednesday with graphing. We'll have a quiz on Friday. Those of you taking the SATs Wednesday, Thursday, or Friday, please make sure your Chromebooks are fully charged. Okay? Make sure you have a calculator. If it's one that requires plug-in to charge, make sure that is fully charged, even though you have one through Desmos, and a pencil. Okay? So make sure your Chromebooks are fully charged. Yes. Okay. So please make sure you have that all situated. All right. You guys are lucky. Extra copy. Come and get them. Thick packets. So. All right. So the next part is solving. Okay. We are just going to recap. Okay, in terms of how we solve these guys first, then we get into more little difficult stuff. Okay, Thursday you definitely will need your graphing calculators. Okay, you'll definitely need your graphing calculators. So for number 1, what would I do? Check. Okay, we would take the square root of 25, and what would our answer be? Thank you for saying that. Plus or minus 5. Excellent. Okay, because we took the square root of both sides and we're solving. How about number 2? X squared equals negative 25. Go ahead, Grace. Excellent. Okay. So here we would take plus or minus and 5i because we have a negative. So this is not a real solution, as we know. Okay. So taking an even root of a negative number will be an imaginary solution. Okay. Now, number 3. We have x cubed equals 125. How do we go about that? How do we solve it? What do we do? Danielle? Good. We take the cube root of either side, and we get x equals 5. All right. How about number 4? Braden? Careful. Okay. So we're taking an odd root, right? Odd root of a negative number can be done. Okay. Cube root of negative 125 would be negative 5. So when you take an odd root, okay, of a negative number, you will get a negative answer. So the cube root, the 5th root, 7th root, you will get a negative number. Okay. If you take an even root, it won't be a solution. Okay. The only time we use plus or minus is when we are solving even roots. Okay. So x squared, when we take the square root of either side. X to the 4th, we take the 4th root of either side. Okay. So we're going to try a few of these. We have x plus 10 to the 6th plus 6 equals 70. What do we do? What's our first step here? Yeah, Sabrina. Subtract 6. Good. Okay. Then what do we do? Yeah, Louise. So we then take the 6th root. Is 6 an even number? Yes. So we're going to have 2 solutions. What is the 6th root of 64? Braden?
2 and -2.
Good. So we have 2 and negative 2. Excellent. Because it's an even root. So we take the 6th root of 64. So we have one solution. X equals negative 8. And x equals negative 12. Okay? So when you take an even root, you're going to have 2 answers. All right? Let's look at number 6. What do you do first? Liam.
Add both sides.
Okay? We add 1 to both sides. Then what do we do? Danielle? Good. 2x plus 3 equals 2. 2x plus 3 equals negative 2, since we took an even root. Okay. What are my two solutions? Lila, what did I get? Okay. Subtract 3. Good. Okay. All right. Excellent. Try number 7 on your own. All right. For number 7, what do you do first? Nolan, what do you do first? And what do we get? Okay. Then what do we do, Emma? Which is 4. So we have x minus 5 equals 4. X minus 5 equals negative 4. So what are our two solutions? Esteban. 1 and 9. Good. Positive 1. Good. Awesome. How many of you did get that? Great. All right. So you will need a calculator for this one. Right? We're always going to round to the hundredths place whenever we can. Okay, just read it through. Given the equation, W equals 0.0167 L cubed, where L is the length. Estimate the length of the coral cod that weighs 200 grams. So how would I set this up? Jack. Good. Excellent. So we would set it up as follows, because we're trying to find the length. All right. Then what do you do? Cyan, go ahead. Before that. Okay, Louise? Good. We would divide by, okay, and we want to round to the hundredths place. Okay, what do we get when we divide? Danielle?
11,960.
Okay. All right, L cubed. Now what do we do? How do we get L by itself? Asad? Take the cube root of both sides. So once you take the cube root, and you could find that A in your calculator if you go to math. Okay, if you go to math, then number 4, which gives you the cube root, or what's another way you could enter this?
1/3.
You're right. Yeah. Raised to the 1/3 as well. And what do we get? 22.88 centimeters. Okay. Any questions so far? Again, this should be pretty much review besides the 4th root, 5th root, 6th root, whatever we're looking for. Okay. Now we are going to see when we have to solve using our fractions. Okay. So if I was to give you x to the 1/2, how would I get rid of that? Someone said it. Somewhere. Nolan? By squaring 8 on both sides. So if you have a rational exponent, okay, this is also the square root of x. So if you have a rational exponent, you're raising both sides to the reciprocal, okay, to get x equals 64. Here is not where you include the plus or minus. You only include plus or minus when you're taking an even root to either side. Okay? What do I do in number 2? Liam.
Raise both to the equal, which would be, in this case, 3.
Good. So it's 3 cubed. What does x equal? 27. Okay? What do we do in number 3? Caitlin. Okay? Negative 2 to the 5th would be what? Braden?
32. Wait. No, it would just be negative. Well, it would just be negative 37.
Excellent. Good. Okay. Number 4, what do we do? CC. Good. Raise it to the 4th. And what does x equal? Go ahead. 16. Excellent. Okay. So very basic. Okay. The next two are also very basic. So for number 5, what would you do here? Say it. The 5th. 5th. Can you see? Yeah, okay. Just making sure. Okay, raise it to the 5th. So we have x plus 4 equals what? 32. And then what's your final answer? X equals 28. Good. Awesome. All right. Now, number 6 looks a little bit different. Everything we have seen has been 1 over something. Now, it's 3/5. So what are we raising?
Raising it, because what we'd have to do is we would have to, I think it would involve, like, roots.
What are you raising both sides to?
Raising both sides to the third, or the 5th. Reciprocal.
Which is?
5 over 3.
Excellent.
So,
Excellent. But you are right for what you just said before that. So you have 2x minus 7. Now, having 8 to the 5/3, what does that mean in radical notation? Esteban? Okay, it's the cube root of 8 then to the 5th power. Okay? What is the cube root of 8? Jack? Okay, then we take 2 to the 5th. We should know these, like 32. Then we go ahead and solve. Okay, so you have 2x equals 39. X equals 39 over 2. Okay, all great and dandy, right? Number 6, did we take an even root or an odd root? Odd, right? The cube root is odd. So, even with rational exponents, when you're taking the reciprocal and your denominator is even, how many solutions should you have? Ma'am? 2. So if we look at number 2 to try on your own, we're going to do this together. What do you have to do first? Blake, what do you do first in number 2? Add 1. Good. So 3x plus 2 to the 2/3 equals 16. Now what do I have to do? Okay. 3/2. Now, is my denominator even? Yes. So if I was to rewrite 16 to the 3/2 in radical notation, what would it be? Go ahead, Nolan. Square root of 16 to the 3rd power. So, what is the square root of 16? 4. What's 4 cubed? We'll have 4 and negative 4 when we take the square root. 64. So we have positive 64 and negative 64 because you're still taking that square root. Okay, now you're able to solve. All right, so I want you to try, finish off number 2, find your solutions, keep everything in fraction form. Okay, then I want you to try 1, finish 2, 3, and then the bottom here, 1 and 2. Okay, give those a try. Let's go through these. Bless you. Right, number 1. You should have gotten x equals 1 and x equals negative 9. When you subtract 1, you get 25, then take the square root. That should have been very simple. X plus 4 equals 5, and x plus 4 equals negative 5, and then solve. Good. Then number 2, we should have 2 solutions. Okay, we have 3x plus 2 equals 64. 3x plus 2 equals negative 64. So we have one answer on the board, 62/3. What's the other? Danielle? Negative 22 as well. Okay? Then number 3 is correct. We have x equals 83/5. You have to take the 6/5 of both sides because you're raising it to 6/5. So that means it's the 5th root of 32, which is 2. 2 to the 6th, 64. Add 19 and divide by 5. Okay? Any questions on 1, 2, and 3? Okay. Then we got down to the warm-up, right? Number 1 is correct, is 35. Okay? Because here you're just squaring both sides and then subtract. Number 2, you add 6, then cube both sides, and you get negative 33/2. Any questions on 1 and 2? Okay, so everything we have seen so far has been possible solutions, right? But not every solution works, okay? If there's a solution, when you check it, meaning you plug it back into your original equation, and it does not work, that is called an extraneous solution, okay? Which you only check for if the directions tell you to, okay? So don't make yourself crazy to check every single problem if it's not mentioned, okay? So why we check for extraneous solutions? Well, you might get 2 possible answers. One might work, both might work, or neither, okay? It's just how it pans out, okay? When you're checking these solutions, you're plugging it back into the original equation. However, this is important. If I have a solution of x equals 4, okay, and my equation is square root of x equals negative 2. When I substitute in square root of 4, I'm just evaluating, so I'm taking the positive root. The square root of 4 is 2. That is not equal to negative 2. Therefore, x equals 4 is an extraneous solution. Okay? So when you're plugging it into one side of the equation, you're taking the positive square root of it. Okay? That's an important piece. You only use plus or minus when you're taking the even root of both sides. Okay? It's very important. People mess that up all the time. Okay? So for example, if I want to check x equals 100, that's one of my solutions, and this is the equation. Well, I plug it into the original. What is the square root of 100? 10. 10 equals 10. Well, this is a solution. However, if I look at number 2, I want to check if x equals 1 is a solution. I'll plug it back in. What is the square root of 1? 1. Does that equal negative 1? No. Therefore, x equals 1 is an extraneous solution. And I write EXT. You don't have to write the whole thing out if you don't want to. Okay? Or you could cross it out that it's not a solution. Then the last one, number 3. We want to check if the square root of 25 is square root of 25 is 5. 5 does not equal negative 5. Therefore, 25 is an extraneous solution. Okay? So, these look a little different. Solve the radical equation and check for extraneous. So, what do I have to do to both sides? Yeah. What do I have to do to both sides? What's that? Square them. Okay. So I have 21x plus 1. However, what's on the other side? Please do not say x squared plus 25. Addison? How'd you get it? Good. So this is, remember, you have a binomial squared, which expands out. Okay? So it's x plus 5 times x plus 5. So you have 21x plus 1 equals x squared plus 10x plus 25. Now, in order to find solutions, we have that quadratic there. So, meaning x squared. We want to move everything to one side in order to factor. Okay? So we subtract 21x, subtract 1, because I like to keep my x squared positive. Okay. And I have x squared minus 11x plus 24. How do I factor it? Sad? Good. So I have x minus 8 and x minus 3. So what are my 2 possible solutions? Danielle? 8 and 3. And I say possible is because we have to plug them back in. Okay? Any questions so far? Okay. So we're going to check out 8 first. Okay. So we're going to test to see if 8 is a solution. So you have 21 times 8 plus 1, and then 8 plus 5. So everywhere you see an x, an 8 is going in its place. What's 21 times 8? 168. And 8 plus 5? 13. And we have, what is the square root of 169? 13 equals 13. So is 8 a solution? Yes, it is. We're going to do the same thing with 3. Okay, so everywhere you see an X, a 3 goes in. What's 21 times 3? Okay, square root of 64. Okay, 8 equals 8. Okay, so both 8 and 3 are solutions. Okay, so I want you to try that last one you see on that page. Okay, example 2. All right, I want you to solve for x and then find or check it to see if it's extraneous or not. Okay, how many of you did get x equals 108? Okay, so you have to square first the 5. Okay, so you get 1/3 x minus 11 equals 25. Then you add 11 to get 36. Then you multiply both sides by 3, which is reciprocal. You get x equals 108. Then we go ahead and check. Okay, 108 times 1/3 is what? 36, good. 36 minus 11, 25. Square root of 25. Good. Okay, so it does work. All right, so 108 is your solution. So when we can, next class, we will be using the calculator. Okay, we're going to solve it algebraically, but then confirm in the calculator. Sometimes it's hard to see on the graph. So when you have, what is this an equation of? The first side. What is that an equation of? Square root, right? On the right-hand side, what is that an equation of? If I was split it into 2. X plus 5 is what type of graph? Linear. So you have a square root and a linear. So if I was to split this into 2 and say do y1 and y2, to find solutions, what are you looking for then? If you graph those two separately on the same graph. Yeah. The intersection. Sometimes you're not able to see it on the graph. That's why we do it algebraically and check. Okay? So I just did this in my calculator and you can barely see where they both intersect. However, you could go to the table to see where they have the same values. That's what we're getting into next class. So it's imperative that you bring your graphing calculators with you. Okay? This also cuts back time. Say if you get a problem on the SATs or a test or whatever it might be, to check your answers, okay, by using the calculator. All right? However, you will need to know how to solve it algebraically. All right? So your homework in the blue packet, 5.3 practice, pages 7 and 8. Okay? 5.3 practice, pages 7 and 8. We have about 10 minutes or so to work on.